All right, folks, so let's go finish the second part of this. We looked earlier about what is a system of equations. It's two different equations, right? And a solution looks like an ordered pair that when you plug it into each equation, it makes both of them true. And so this ordered pair, this XY combo number, makes the equations true, and you'd say yes. What happens if it only makes one of the equations true, or if it makes either one of the equations true? You'd say it's not a solution. But we never did look at, well, how did they find the solution for this system, right? How did they find this solution, the XY, for the entire system? Well, there are different ways that you can do that. There's actually 3 different ways that we'll be learning this year. Today I'm just going to show you one, graphing. Now you already know how to do the graphing, so this will be a review, but the new twist is that we're not going to put just one line on this graph, we're going to put 2 lines on this graph. So let's look at the first equation right here, y equals x minus 3. I'm going to color code this red, and so our line is going to be in red over here. But first off, go ahead and put a 1 in front of that x right there. Now, when you go to graph it, the first thing you need to do, because this is in slope-intercept form, is still the number that's adding or subtracting behind the x. So this is minus 3. So I want you to draw a little arrow and say, hey, this is my y-intercept. We know it by a little nickname known as start, and it's literally just negative 3. I know it says minus 3. We're going to think of it as negative 3. So this y-intercept number, the start number, negative 3. That means where's the line going to touch the y-axis? Well, this is 0, negative 1, negative 2, negative 3. So we need to put a dot right here. Now, the second number that we're using, the number that's multiplying your x right here, so I'm literally circling it, this is called your slope number. What's the nickname that we learned about it originally? Your step number. So it's positive 1. Let's put a positive 1 right here. Now, you might also recall that for a step number, we need to turn it into a fraction. So we're going to put a positive 1 underneath it, not because it's a positive 1, but anytime it's not a fraction, we put a positive 1 underneath it. And the top number, if it's positive, we go up that many, and the bottom we go over this way. So look how we're going to use the slope here. We're going to go up 1 and to the right 1, and we put a new dot. Up 1 to the right 1. And it builds stair steps this way, right? And we can always stair step our way back down this way. Whatever the pattern is, we continue it on, and you can see where we have all of these wonderful precise dots. And I would make sure that we really don't draw the stair steps in if we can help it, because it's going to get a little crowded with the second line that's going to be through here. But I always tell my students, try to extend your first line as far as you can normally. Sometimes it's a little frustrating, but at least get 3 or 4 dots there if possible, because we don't have any idea where the second line is going to go. And so that's how we do this. We have to graph the second line now. So let's go graph the second equation right here. Let's put in a 1 right here in front of the x so we can actually have a number. And let's go steal our, what's this called? Hopefully you're saying it's the y-intercept. That's our start number. And in this case, it's negative 1. So we come here to our y-axis, and we're going to put a dot right here at negative 1. Okay? So now we come back for our slope number, or otherwise known as our step number. In this case, it's also negative 1. This is not a fraction, so you take the number and you always put a positive 1 there. If your top number of your slope is negative, I want you to go down that many, and then we would go over this many here. So let's go use this. We're going to go down 1, and then what's this right here? Down 1 and to the right 1. We bump into this exact same dot, and that is what we want. We want the 2 lines to bump into each other. The exact point where the 2 lines intersect is the solution, so we need to grab this ordered pair. Just remember, we need your x value first. So where is this dot underneath the x-axis? It's underneath positive 1. Okay. Where is this dot at on the y-axis? Well, over here it would be at -2. What's the solution to this system of equations? What's the x-y combos that makes both of these equations true? The only combination that works is where the two lines touch, and it is 1, -2. So this ordered pair makes both of these equations true. And that is how we do the graphing method.